Kia ora. This is a great little simulation to build equilibrium constant expressions. So remember, the product is the numerator and the reactants go into the denominator, and any coefficient in front of the number gets raised to the power. So for example, copper is a reactant, so it goes into the denominator. There's a 4 in front of ammonia, so that needs to be raised as a power, and the reactant goes on top. And you can check to see whether you're correct. So next question, the same thing. We've got the reactant going into the denominator, the product going into the numerator, and any coefficients get raised to the power. And that'll be correct. Now we've got something slightly different. We again do our reactants in the denominator, and our products go into the numerator. However, you must be careful of states. So if I drag that into the numerator, then if I click submit, it says it's incorrect. The numerator is incorrect. And the reason being is that water, being a liquid, doesn't change its concentration. And so that gets absorbed in the equilibrium constant itself. So you don't add solids or liquids into an equilibrium constant expression. And now you can see this is correct. So here we have, again, all gases. So this is simply your reactants go into your denominator, your products go into your numerator, raised to their power, and it's correct. Here we've got now aqueous, liquid, aqueous, aqueous. So remember, our reactant, if it's aqueous, goes into the denominator, but a liquid does not. But our two products are aqueous, so they can go into the numerator, and that would be correct. Then we have this one where we have aqueous, aqueous, solid. So our products will go into, sorry, that's a reactant, will go into the denominator, and it's raised to its power. However, I cannot put this in. If I put that in as a solid, it says it is incorrect because it is a solid, so the concentration doesn't change. And so I have to take that out, and it becomes 1 over. And notice this is not written as a solubility equation because we've got the solid on the right-hand side. And now you can see that is correct. Here, though, we've got a solubility equation because we've got our solid on the left-hand side going into solution. So we do not put this into the denominator because it is a solid. And we do, though, put the ions into the numerator because they are the products. So have fun exploring this. Kia ora.